It's a little skewed right.
The camera? Oh, very nice, Corey.
Indeed.
So, we've got, according to Corey, a little skewed right curve. I'm tempted to agree with him. What I want to do is I want to be able to pull similar values that we got when we had raw data from this group data right here. Now, I've broken it down by classes of width 3, so 0, 1, 2, 3, 4, 5, 6, 7, 8, and so forth and so on and so forth and so on. So what I want to do is I want to kind of look at that and come over here and do key data grouped. Because the methods that we'll kind of attack here by looking at the data grouped is probably going to be, the methods are probably going to be more useful to you when you consume research journals. Because very often, when you consume research journals, when you're looking in textbooks, your data is going to come to you either in a distribution or in graphical form. Very rarely are you going to see what we saw on Monday, which was your actual raw data kind of laid out for you like that. You're going to get something like this. So the important thing is being able to approximate these values from something like this. So we've got an X bar to find, we've got a median to find, and we've got a mode to find. Let's find one. You pick any one of the three off of this graph and find it. Any one you want. Any one you want. We've already done it with the previous three graphs. Just apply what we did back then to this. Go ahead, be brave.
3 to 5 mode.
3 to 5 mode. Corey says 3 to 5 mode because
It's the most.
it's the tallest bar. It's the mostest. The mostest to use your term. Charge me a nickel for using it. So 3 to 5. So your mode's going to be in the 3 to 5 range, and there's absolutely no problem with just calling that 4 if you want. Just pick the value in the middle. There's no problem with calling that 4. No problem at all. No problem at all. Fair enough? Notice we're off a bit from the mode of the raw data. And that's because there is some, it's a pretty small data set. I mean, we had 32 keys. It's still a pretty small data set. As data sets get larger and larger, these values tend to get closer and closer. All right, median or sample average. Your guys pick. Your guys pick. Which we do next?
It's median.
Median next? I like that, because it's not computational. It's just a matter of chopping. So let's begin chopping. Let's chop the 16 that's over here with one of these ones that's over here. And that'll leave 11 left, correct? So let's chop those 11. Let's keep track now. 1 plus 3 is 4. That leaves us 7 more in this bar, correct? But then whatever's left is in this bar. Everybody follow that choppage? Yeah. So the median's also going to fall in. No, you didn't follow that choppage. Okay, sorry.
Yeah,
we have to find the, there's 32 data points, correct?
yes.
So we have to find the 16th and the 17th ones. That's where the geographic center is. Let's just do it this way. So here's 12 of them. The 13th, 14th, 15th, 16th, and 17th are going to be in this bar. 18 through 32 are going to be out there. So by the chopping, what I was trying to do is get rid of the extremes and work my way into the geographic middle, if you will. Is that fair? Yeah. So 16 and 17 are also both in there. So I'm going to call the median 4 as well. Call the median 4. 3 to 5, but you can also just call it 4. You can also just call it 4. Pretty close to the 3 that it was over there. Average. This is the one that's the most computational. And I'd like to mimic that over here. Now, we used the balance idea before, which I liked an awful lot. The problem with the balance is, where's the balance going to be? What do you guys think?
Right about it.
Right about here? Whoop, maybe here?
No.
Right about there.
Right about here? Because now, there's a couple things that are kind of making it confounding. Number one, you've got big bars here. But number two, you've got a tail out here, a counterweight. So those two things together make it hard with any certainty or precision to kind of put my finger at the fulcrum. So what I'd like to do instead is figure out a way to do this on this to get the average. Now, we can't do it exactly as we've spoken of before. We can't do it exactly. We can't do it exactly because we've lost the raw data. But we can use this idea of a distribution, though. We can use this idea of its distribution to knock it down. I'll do it over here on the side. So, number of keys. Here's the classifications we have. We've got 0 through 2. Let me swing the camera over too. This might be something people want to see. Yeah. Go, go, GoPro. 3 to 5. How far down do we have to go, friends?
21, 23.
Well, but we only have data up to 15, right? Sorry, I have a template I just dropped keys into, so sometimes I have zeros. I definitely want the 12 to 14 though to show that 15 through 17 is actually separate from it.
Has anyone ever had 23 keys?
Hang on. Because I'm that guy.
You're gonna find the data.
Well, there's all the data. Somebody had 28 one year. Yeah, there's the historical data right there. There he is. Right there he is. There he is. 28. There he is.
What was he doing with 20?
I don't know. I don't ask questions. I just say, okay, there it is. That was spring 2011. Good term. Good term.
Carry around 5 pounds.
Carrying around 5 pounds of keys. Maybe it's cross training. Who knows? And then we've got the frequency column over here. So that's 12, 15,
3,
3.
1, 0, 1.
Hey, friends. Very helpful. So, what I want to be able to do is essentially, remember what Tabitha said the average was. It's like having a big barrel here that everybody, as they walk in, they throw their keys into the barrel, and then we split it up evenly. I would love to know how many keys are in that barrel. But all I know right now is that this is how many people contributed keys to the barrel. We've got 27, 32. All I know is 32 people contributed keys, but not how many keys they contributed. So what I need some kind of a way of measuring how many keys they contributed. Well, here's the problem. 12 of you had between 0 and 2 keys, right? But I don't know how many had none, how many had 1, how many had 2. But I'd like to assign a number to each of those people. So how many should I say each of these people have? Just call it 1. Average at 1. Make the assumption, and remember, you don't know this, but make the assumption that everyone in here had keys that were equally spread throughout the bar. That may or may not be true for each bar, but you'll see what happens in the long run here at the end. So basically, if everybody has the same number of zeros as ones as twos, it's the same as everybody having just 1 key as far as a complete total. 0 plus 1 plus 2 is 3, and 1 plus 1 plus 1 is 3. So let's call that one. I'm going to call this the X column if you don't mind, because that's actually your data now, your X's. 3 through 5, we're going to say they all have 4. Yep, 4. 6 through 8, they all have, I think you get the hang of it. 16. There you go. So 12 people walked in the room and each threw a key into the bucket. 15 other people each walked into the room and threw 4 keys each into the bucket. 3 people walked in and each threw 7 keys, and so forth and so on. So how many keys are in the bucket now?
32.
That's how many people threw keys into the bucket. How many keys are in the bucket? How can we figure that out from this data?
Adding your averages?
Exactly, yeah. I'd say, well, can we do something a little more slick if you don't mind, Raphael? Multiply this times this and then add that. Is that okay? I mean, yes, we could do, okay, that's 12 ones, that's 1 plus 1 plus 1 plus 1, 4 plus 4 plus 4 plus 4, 50, and that gets tedious.
Yeah.
So let's just create one more column. It's okay with you guys.
It's okay with me.
Okay, okay.
We'll just do an X times F. These are the jokes, kids. X times F. So 12 keys in total were contributed by these 12 people. 60 keys in total were contributed by these 15 people. 21 keys from these 3 people. 10 keys by that one person. Nobody from these. Nobody gave 13. And 16 keys from that person right there. Add that column up, and that should be an approximation of how many keys we actually had in the room that day. And I'm going to have to scooch this over a little bit to make room for it. Summation of F is 32. So this summation of XFs. It's okay if I just do that? Just summation of XF. That's all I'm doing, multiplying and then adding. Let's see, we got 33, 93, 103. I get 119. Is that right?
I concur.
Okay, 100. Concur. This guy is mostest in his concurrence. 119 keys. I think we now have 2 numbers that give us approximations of what these 2 numbers over here are. The summation of F is the same as N. And the summation of those XFs is the same as this numerator up here, because that's how many keys over how many people. And that's how many keys over how many people. So let's check it out. We got how many keys over how many people had those keys. So that's 119 out of 32. What does that come out to a tenth, my friends?
3.7.
Say that again?
3.7.
3.7. Check out our average over there from raw data. Keys per person. So you see now that whatever offness we get by assuming the middle cancels in the long run. Look how close, that's the true average. 3.9 keys using the raw data. And yet we got 3.7 keys, which is essentially the same number, using grouped data in a histogram. Pretty rad. Pretty rad and pretty powerful. It never comes up, I shouldn't say this, I was about to say it never comes up exact. The previous class, it came up exactly the same number. This number 119 was exactly the number that they had when they had raw data. That always happened once in, say, 20 years of doing this. But it always comes up close. And that's because, now, as I was saying, we assumed all of these folks had 1. You know that's not true in that first bin, because that's where the mode was. Remember your mode was 2? There were 8 2s. So of these 12 values, 8 of them were 2s, which throws out my argument that everybody in here averages to 1. But remember how we overestimated we underestimated this one? We overestimated the one right next to it, because there were a whole bunch of 3s in this one. So if you overestimate this one and underestimate this one, it washes at the end. And that's the whole reason it works. That's the whole reason it works. It's called the law of large numbers, which is not important to memorize, but it will behave that way for you. It will behave that way for you. Totally rad. You do lose a little bit of precision, as Mike pointed out. You lose the precision, but what you lose in precision, you gain in utility, because you can do this on any histogram, on any distribution. And that's what you're going to have most time. I have a hell of a time getting raw data from research studies, because very often they hide it, and rightfully so. They had to work their butts off to get it. They'll give you the synopses in a graph. Good for them. Good for them. And I would hide it too if I worked that hard and used grant funds to get it and they just give it away. I mean, at some point you give some of it away as information. But the raw data, sometimes you can't give it away for whatever reasons. But it's nice to be able to pull these values from a summary display. Cool? Okay, keys is great. They're cute, very cute. But there are, what you just did here is the example. I mean, it still measures of center. It's still the idea of, it's nice that we'll break it. It still measures of center, average, median, mode, at the very end. But there's one average you guys care about an awful lot as students.
Dead.
Say that again.
Dead.
Oh!
There you go.
Grade point average?
Wow, that's amazing. That's a sign of our times right there, Chris.
Yeah, it is.
That is a sign of our times.
We don't care about
I've
grades
never
anymore.
gotten that
We care
response in
about
20 years.
dead.
Wow. I've been told that's the next bubble.
Great.
Is the student
You should
debt
find
bubble.
some info on that and let's set it up on some graphs and look at it.
I was
We could
supposed
do
to
that.
send in some.
We could do that. Press the hell out of it.
I know, right? I don't know if I'm gonna
I don't know if
solve
I see
that
that
class.
No.
I just read a press release, though, from COCC, College Relations, just put a press release out. Speaking of the inflated amount of debt COCC students are carrying compared to even 10 years ago. Wow. The trick is getting, very often what they'll tell you is the average college student carries this much debt.
What does that mean?
It doesn't mean anything. That's the problem, is because unless I know what the distribution of that debt looks like, that could be a high overestimate or a low underestimate. And I can't just ask, say, a handful of people at COCC, because you're not necessarily representative of the entire population. You're getting financial aid or borrowing debt based on COCC's rates, which are still very affordable compared to, like, say, Columbia University, so, or even OSU or U of O. So it would be a challenge to track that. Send me an email, though. Send me an email to remind me to do that, and let me dig in and actually track that down. What you got?
But I think you also have to look at the availability of jobs. Like 10 years ago, students could get jobs that would pay off their loans way faster than they can now.
So we can maybe go apples. Come here one more time.
Totally.
Kelsey, we can maybe go apples to apples by looking at student debt incurred, say, in senior year in college. So before the job kicks in, unless that somehow measures into how much debt or how much money they're awarded in the event of, say, a Stafford loan or a Pell Grant or something like that. I don't know if that plays in. Does it, Tammy?
Well, I was just gonna say, Kelsey, are you talking about they were able to work during school so they didn't have to?
No, I'm just
Afterwards.
You're
wondering
talking about afterwards.
Talk about afterwards.
Yeah, okay.
So maybe what I can do is go a little more apples by only looking at, say, senior year's debt accrued up to senior year, not say 5 years after graduation. Good point, which I hadn't thought of either. Very good point. So maybe, again, remind me of this, and I'll try to start digging up some values.
What if you do it like per what kind of degree they have? So like like a transfer degree or
That,
bachelor's.
well, I would have to do that, because a transfer degree versus, say, an associate's is going to cost twice as much, 3 times as much. I'd also have to weight it for the type of school, or you know, if it's a university, is it a college, is it a 2-year, is it a 4-year? I'd like to keep it apples as much. What I'm trying to think about, maybe I can do, if I can get this data for next week, it can become part of your take-home exam. So you guys are building your take-home exam, hopefully, right now. Unless it's too depressing to talk about.
No, it's not too depressing to talk about.
It's
It needs to be.
Well, it needs to be talked about, of course. It's a reality, yes. So remind me,
Don't sweep it under the rug.
Crystal, and we'll get on that quickly.
Okay.
The average I was hoping you would say was GPA. a little less volatile. And I thought a little more common up until 2013, stupid Federal Reserve. So anyway, what I wanted to do, how many of you have calculated a GPA before? 2, 3, 4. Okay, 4 of you. Good. 4 of you out of 32. So I think that's not good. Let's figure out how to. Because the reason I'm saying that is what you just did here with keys is the same thing as a GPA. They're both examples of what's called a weighted average or a weighted mean. They're both examples of that. So let's just do another example. So this is example 1, weighted mean. And the reason it's called a weighted mean, is because your data, which is in this X column, 1, 4, 7, 10, 13, 16, that's your data. In order to get the average of these data points, you don't add them up and divide by 7. You have to add them up with respect to how many times each one occurs. These are called weights. Statisticians call them frequencies, the rest of the world calls them weights. So you don't just go 1 plus 4 plus 7 plus 10 plus 13 plus 16, divide by 7. You have to do this times this because that counts 12 times. That counts 15 times. That counts 3 times. Those are the weights applied to the data. When you have raw data, there are no weights. Everything gets counted one time. But when you have group data like this, you have to account for those weights as well. And a GPA is a perfect example of that. So example number 2, GPA. GPA. We're also going to talk about GPM1 and GPM2 by the end of the day today. Again, weighted means, example number 2. Let's create a schedule for a student at COCC. What classes is a student taking?
Statistics.
They are, of course they are. Of course they are.
Microbiology.
Statistics, nutrition,
Total fit.
micro, of course, total fit. Micro, total fit. We have micro in there too.
Art in there.
Total fit's kind of an art form.
Yeah.
It's
And in all
It's
honesty.
only one credit. You got a 4 credit, a 4 credit, a 4 credit, a 1 credit. There's no 3 credit class in there.
So it's not-
I'm going to make
You can take 13 credits.
nutrition a 3-credit class. Just because you said that. That was very, very good, actually, Athena. It's a good point to bring that up. Because, now, before we get back into credits, I love that, by the way. How did we do in these classes? How did we do in statistics? Of course we did. Of course we did. How do we do in nutrition?
B.
B? Let's make it a B minus just to be saucy. Micro, which micro was this?
Microbiology.
Biology.
Yeah, I'm bad at that.
How we doing that? A D?
C.
So a C.
No.
C. No, C.
See,
Who gets an A in microbiology?
I'm gonna get an A in microbiology.
Let's just make it C. C plus. Let's just make it C plus. There you go. C plus it is. We'll get an A in total fit.
Solid.
So my question now is, based on that schedule and those grades, what is that student's grade point average? Which is what's on your transcript every term. You have a cumulative grade point and you've got a current term-by-term grade point. What is that student's grade point average based on that schedule and those results right there after
Probably like
11?
a 3.
Say that again.
Probably a 3, but I don't know.
Cassie's got probably a 3. Tell me why you go with 3.
Just because.
Where did the 3 come? Where did numbers come
Well,
from?
because you got a C plus and a B minus, and a C plus or C's average out to a 2, and B's average out to a 3.
So she's kind of plussing this, canceling this, kind of knocking things. Okay, I see where you're going. I see where you're going with that.
She's chopping. Like
There is a sliding scale. It's slightly qualitative, slightly quantitative. When you go A, B, C, D, and then F, A is 4, B is 3, C is 2, D is 1, and F is 0. And then there are pluses and minuses. Every time you drop one letter grade, it technically is a third of a point. So when A is 4, then A minus is 3.67, a B plus is 3.33, and a B is 3. A B minus is 2.67, A C plus is 2.33. A C is 2. See what's going on there, friends?
Yep.
So we have to get that in here somewhere. So obviously the A. What I need to see, friends. I need to see these two columns right here, there. Because this is how we're going to, these two columns right here, the X column and the F column, that's going to be how we're going to be able to turn this into something meaningful. So we need to create the X and the F column. So let's come over here. X. This is essentially your grade. Essentially your grade. So for statistics, you got an A. That's 4, I forget what they call that. Quality points, maybe? There used to be a name for that. Quality points, 4 it is. B minus, that translated to,
3.3 or something?
I think it was 2.67, wasn't it?
Yeah, 2.67.
Right, because a B is 3, so it's a third down from that, 2.67, beautiful. C plus is 2.33, I believe. Check me on that. Yeah, it's 1 up from a C. A C is 2, a third up, 2.33, and then the A again is a 4. Fair enough? Okay, good. Tempting right now to average those 4 numbers. Very tempting. I mean, it'd be very easy to do, but if you did that, that would be the same as adding these 7 numbers and dividing by 7. So you could add those 4 numbers and divide by 4, and you would get a number, but it wouldn't accurately represent what your GPA actually is because we haven't, as Athena pointed out, accounted for
Credit weight.
your credit loads, the weights, the amount of time you spend in these classes is tied, well, theoretically, the amount of time per hour, the number of hours you spend per week in a class is tied to how many credits. So a class like Stat, you actually have a credit load. I'll call it F, but this is really your credits. Or your weights. I mean, all these words mean the same thing, the weights or the credits or the frequencies. You should count that 4 times. 1 for each of the 4 hours of the class you're in each week. Nutrition, I think I made that a 3-credit class, didn't I?
Yeah.
What the hell, why not? It's now a 3-credit class. Micro, what's micro?
4.
Is that 4 as well? Doesn't that have a lab attached to it?
It does.
But it's still a 4-credit class?
Yep.
Interesting. So you're spending 5 hours.
The bio,
All labs.
Aren't some of the science classes 5 hours?
Not last year.
200 level.
I say none of
Five.
the
200.
5.
200 sequences are 5, the 100 sequences are 4. Interesting.
the level you're at.
Is it the same time in class per week?
I think so.
It's more, the 200 levels
Take
are
a
more.
Full class and then you still.
Well, the reason I bring this up, Chris, is because the calc classes at COCC are 5 hours a week, but only a 4-credit class. So I was curious to see if the 100 level bio class is also filling that.
Yeah, the bio classes are 5. I go.
Even the 100 level ones are too.
I'm
Yeah.
pretty sure.
Okay, but for some reason they're called 4 credits. Okay, for whatever reason. The magic.
It's unfair.
I mean,
Well,
labs-
I don't understand why it works, how it
labs
works, though.
is
And then total fit
3A.
is the hardest 1-credit class you'll ever take.
Right.
Hardest 1-credit class you ever take. So anyway, we now have essentially this XF column over there. The one thing we didn't have to do, this didn't start from range values like this. We didn't have to take that midpoint, because the midpoint is a static value. You don't have to worry about it. So now I think we can continue with our XF column. 4 and 4 is 16. 2, oh God, that's 2/3. That's going to be 2 plus 6. Is that 8? 8 and a little bit of change?
Yeah, 8.0.
Yeah, 8 point, it's 8 some change, isn't it? Yeah, it should be 8 exactly, because technically speaking, that is 8/3. Round it off. So 8/3 times 3 should be 8, but whatever. This is going to, and this should technically be 12,
Yeah.
but I think it's going to end up being just below, right? It's going to be like 11.9.
No, I got 9.32.
Oh, excuse me, I'm sorry. I'm calling it 3. 9 point, thank you, 9.32. This should be a fraction as well, and that's just 4. Beautiful. So those are, I don't know what to call those. Like over here, we call this number of keys. I don't know what to call this, number of points, I guess. So anyway, I guess number of grade points. I guess that's what it is.
Yeah.
That's your quality points, but it's called a grade point average. So technically speaking, it's, if you will, it's your number of grade points. So let's add them up. We get 0.33, 24.33, 33, 37.33. Did I do that right?
I concur.
You could, that was just.
Okay, Leonardo DiCaprio.
So our GPA is going to be that divided by 4, right?
Yes.
Divided by 12?
Divided by 4, right? Because there's 4 numbers added together,
Yes.
right?
Yeah, then you get 9.33.
12 credits.
Divided by 12.
Right. We have to divide by the number of credits in the load, which is this column right here, 12 credits. You don't divide that by 4. Otherwise, you have a GPA of like 9 or something like that.
It's overnight.
Right, exactly. Exactly. We have 12 credits, so you have to take your grade points or your quality points and divide them by the number of credits you've taken. So your GPA in this term is going to be,
3.11.
there you go, 37.33 divided by 12. I trust the math, 3.11. There's your GPA. There's your GPA. Now, I'm not saying this is fair. I'm saying that's what it is. That's how a GPA is calculated. What's nice about it is you can use it to calculate what you have to get in certain classes to get a certain GPA. You can also use it to say, like, okay, if I know I can't pass micro with anything higher than a C, should I dump it on week 7 to get my GPA, to keep my GPA high enough? These are the kind of questions that will help you answer. I'm not saying it's fair, because it can show skew. It can show skew. GPAs tend to, just like any other skew distribution, they pull towards your low grades. Especially if you're on average a pretty good student. If you have a bad class, the average will pull towards that bad class. And an even more extreme case, I had a student a few years